Okay. Today, my presentation is titled Building Integrated Cyber Infrastructure for GeoScience through Geospatial Service Web. Professor Gong Yang and Wu Fayi and Dr. Zhong Tong are absent today, so I'm on behalf of them to deliver this presentation. First, let's talk something about the background. We know about the interoperability it has been a long issue because of systems of the following abstracts about the data source, data models, and supporting systems, coordinated systems has caused heterogeneity of geographical information. And thus at 3 levels, data, information, and knowledge, we summarize the 3 research problems. Is it possible to share data directly and online instead of downloading, transformation, or merely transfer? The second is it possible to share processing algorithm directly and online to get processing results? The last one is it possible to integrate distributed processing algorithms online to form a GeoScience model and share this model and the results of this model? We know recent trends in GeoComputation areas has moved from data sharing and mapping to web-based geoprocessing and toward a service-oriented framework supported by high performance computing. To address above mentioned problems and follow recent development trend, we propose Geospatial Service Web and aims to address the needs for sharing large volumes of geospatial information. In the book, Geospatial Technology for Earth Observation, the chapter 13 is about the Geospatial Service Web. The definition of Geospatial Service Web. Is it essentially a web service-based virtual platform that integrates geospatial resource acquiring, intelligent information processing, and knowledge discovery services with high performance computing infrastructure and sensor web supported at the back end? Essentially, Geospatial Service Web refers to a system framework for timely discovery, retrieval, processing, and integration of geospatial services. This slide describes the architecture of GSW. There are 3 levels. The geospatial resource components level is about the sensor network, computing, and so on. The second one is geospatial service components, is mainly about a service such as registration service, sensor data, server training, and searching service, and so on. The top level is about the geospatial application component, is visualization development platform, and the other application tools. This is about the logical architecture of GSW. There are several kinds of resources. Data resource can be gotten from sensor resources by data acquisition service, and the information resources can be gotten by processing service and the compensation service. And the knowledge resources can be gotten from spatial information service by knowledge discovery service. In today's presentation, I'm not going to talk too much about the GSW's theoretical issues. Instead, I will present an implementation of GSW, namely GeoSquare, which is currently under development at Wuhan University. From this slide, we can see GeoSquare has three visual components: the portal, the Registry Center, and the GeoChaining. The portal is an entry point for users to get access to web-based processing tool and the service. Through Registry Center, anyone can register geospatial resource data tool service and map to the Registry Center and share with others. The GeoChaining is about how to modeling geospatial service to chain and execute. And all of this service can be OGC, WMS, and other instance service, and also can be extended service. This service can be executed in HPC framework. The portal URL is www.geosquare.org. By means of a simple interface, users can access data and service registry center and download GeoChaining and the related document. Registry Center supports fast registry retrieval and metadata of various of geospatial resources. These resources include data, service, knowledge, and sensor web. GeoChaining is actually a united platform to design, implement, deploy, and monitor GeoService chain. The goal of GeoChaining is to facilitate the transformation of geospatial data to information or to knowledge. GeoChaining is deployed as the visualization tool for the data processing and the result visualization. The architecture of GeoChaining includes three tiers: resource, server, and client. Resource tiers is about the data, geoprocess, service, and data service. The server tier is about the data registry, center service, registry center, and monitor and people engine. The client tier is a virtual integrated modeling tool, include a series of functions such as register client, data visualization model, and web service, invoker, and others. This example about metadata in GeoChaining is image data metadata such as data size, image data size, and data type, and the bounding box, and others. GeoChaining and Registry Center shares the same resource database. So in the left view, we can see a lot of geospatial resources that have been registered in the database. This is a WMS visualization. The central function of GeoChaining is the visual modeling of comprehensive service chains. By using model elements, we can create a service chaining manually or edit the service chaining templates. Our editing and modeling work can be done by simple dragging and dropping, as well as property editing. These slides show a rather complicated flooding simulation service. Consists of 7 datasets, 7 services, and would produce 3 results. The system can also offer a graphic interface to track the job status of service chain. The service could be executed in parallel. The underlying task mapping mechanic can also automatically divide the task into sub-tasks and promote computing efficiently. The visualization results are shown in Google's black color. Represents the simulated flooded areas. Other statistical data can be visualized too. So we try to establish an open GeoComputing platform and encouraging more people to participate in the future development of GeoSquare. We provide design and development documents API. This slide lists major technology used in GeoSquare. Most are web program techniques. Conclusion: Geospatial Service Web tries to provide a highly intelligent geospatial middleware and integrates various geospatial services through the internet based on interoperable web service technologies. The development of the GSW focused on the establishment of a platform where data, information, and knowledge can be shared and exchanged in an interoperable manner. So I will try to show you something. If this is the portal of GeoSquare. In this portal, the Registration Center, GeoChaining, and some download menu about the document and the tools. Let us see the Registration Center first. In the left view, some maybe first we can log in. Yeah, you can also register a new users. So after you log in, the show will list some nodes such as data processing service and knowledge sensors. You can add some yourself image and register to the registration center. You can also query your interesting resources, such as image. You can input some parameters such as bounding box and data type. So these are your interested image. Also, you can query some WMS. This is about the registration center. You can quickly register and query some special resource. About the GeoChaining. In the portal, GeoChaining provides simple functions such as list the model that have been registered in the registration center and invoke. If you want to create your own model, you can download a package from here and install the package and log in. So we can find in this GeoChaining, the tree view, the left tree view is same as the tree view in the port because they share the same database at Wuhan University. These resources are also listed in the tree view. We can click in the tree view and locate the position of these resources. These are some WMS. We can also display the WMS map on the GeoChaining. This WMS is about the Canadian uranium deposit. So we can create our self model. By dragging and dropping these resources, such as data and service to this window, the system can compose these resources to geospatial chain. Now, in this tree view, some model are registered to the registration center. We can select one to demo. And this is Poyang Lake geospatial chain. It's about flooding simulation. We can invoke this model. And input some parameter, mainly about the output file, the path and the file name of output file. Okay, create a SOAP message and send the message. If the network at Wuhan is okay, we can say the status of the training. Let me try. We can say there are 7 services, services, and every services are divided to sub-job, sub-task, and about the process of service. These services are executed parallel, and sorry, it doesn't work. So we cannot see we cannot track the status, but maybe we can see the results. The model is running. The result is just like this one, like this slide. The result will be 3 files. One file is about the picture before flooded. The second one is after flooded. So the black color is about the flooded areas. This is maybe before flooded. Okay, this is after flooded. The black one, the black color is the flooded areas. So we cannot say we cannot track the status. Yeah, but I think the GeoSquare can model Geospatial Service to GeoChain and invoke. It try to transfer geospatial data to information, even to knowledge. So that's all. Thank you.
Thank you very much. And it's always very difficult to give someone else's talk, never mind someone else's demonstration. So I think that was a really remarkable effort. Do we have questions before we move on? Questions for our speaker? Well, I guess I'll ask one. Are you okay with questions? Is that all right? Is that fair? Doesn't seem fair. I noticed that you use the business process execution language, BPEL, as the workflow engine. Could you say why that was the choice, and maybe a little bit about what its advantages and disadvantages might be?
You mean the workflow? The
workflow engine, yeah, BPEL.
Sorry, can you repeat your question?
Why was it chosen? Why that workflow environment?
Why the workflow is running in people environment?
Yeah.
I think now people is the most popular for the workflow. We can also transfer to other engineering, such as Oracle also provide the workflow. We can also transfer to Oracle Oracle also provide such as a language to describe the workflow. People is almost from our choice. The default, the should disadvantage.
Sure.
I recognize the Eclipse SOA platform that my team developed for the Deutsche Post and then contributed to Eclipse. Sopra is the team. And so, a lot of the things like the payload, the request, response, we provided the service designer for our enterprise SOA. And Beeple is the language that we used for chaining our services. And what's new for me in seeing this, it's kind of exciting to see something that I worked on in my old life in Germany as part of the Deutsche Post, and to see how an enterprise can contribute to an open source community like Eclipse, and then the academic community can take that up. But what is really special and neat, because we were dealing with boring business things, is to see the integration with Google Earth, and to see that really in a geographic science context. But I wanted to add that because I'm watching this and I'm like, I've helped write some of that. So Beeple is a great business engine. I'm sure there are others.
Thank you. Are there any more questions before we move on? Okay, if we could thank the speaker once again. Thank you so much.
Thank you for your time.